Well, hey again. I'm afraid it's going to be technical again, but I want to explain a bit more about the architecture and the whole approach that we took with our platform. And I think it's probably a bit of a new software development paradigm. That's at least what I try to explain. Yeah, so a bit of a history. We did the first PHP version in-house when we were developing Helt Normalt. I don't know if you know, this is like an entertainment site, pretty big in Denmark and throughout Scandinavia. And it was the paper that we did about that. We presented it at the W3C a workshop, which was the first workshop where we're talking about the linked data platform specification, and Tim Berners-Lee was there, so I got to meet him. That was a nice achievement for me. And since then, we have developed a Java version, which comes in 3 layers, so to speak. And the server is just simply responding to linked data requests by sending them further to the Triple Store as describe queries, and then the client extends the server and adds the layout functionality, basically the client side with XSLT, and also processes the sitemap. And then on top there's the platform layer, which handles stuff that you need to implement multi-tenant applications, such as user accounts and authentication, authorization, and also faceted search and so on. So this was the content from the Helt Normalt page. It used to be called Wolf Morgenthaler before. Yeah, now they have launched a new version actually. So the motivation behind that code and that project was that we wanted to replace the old code, which was written in the PHP Zend framework, I think, and based on a MySQL Triple Store. And we used the object relational mapping and so on. And we just could see there were layers and layers of code that we felt could be avoided somehow. And it turned out to be true. And in this case, this is not PHP architecture, but this is Java enterprise stack, I think. And you can see how many layers there are to implement a web application. I mean, how many there can be. So we thought we can simplify this somehow. We could avoid some of those abstractions and just make it much more straightforward. So over time, the design goals turned out to be the following: that we want the platform to be generic software and work as a processor. And in the same way, it's also a state machine through which the declarative description of the application runs, and then the processor responds to requests. So basically, the processor itself is finite. You don't even have to touch it in the ideal way. What you need to do is to create an ontology that defines this declarative structure of your application, and then just run it on the processor. So there are a few analogies with this. For example, XSLT works in a similar way, where you transform the XML document into something else. And functional languages is also a related thing, because their code is data itself. So what implications does it have when we can actually make the application to be data itself? So it means we can make those applications distributed. Let's say I could load a remote description, remote sitemap of the application into my own, and then extend it maybe, or change it, or fork it. And then the applications could be managed collaboratively, for example. And the biggest part of the cost is probably developer hours. And if we reduce the need for software code, or just minimize it to some finite amount, then it's also like huge cost savings if you think about that Java stack and like how billions and billions of dollars are spent on writing that code. So here I have some comparison from the Helt Mail project where you can see on the left side, this is statistics about the code, number of lines and files basically. So the numbers on the left side are for the new version, and for the old PHP version, it's on the right. So if you look at the bottom line, so it says how many lines of code the platform itself took, and then the new version of the site actually handled 15 different types of content, while the old one only had just one comic strip. And this is basically by orders of magnitude, different numbers. And then this also illustrates pretty good what the effect was when we deployed the new version during week 41. So that's how the server load dropped, because there was much less code to interpret. The stack trace was many times shorter. Well, this is probably not totally fair because some of this processing was offloaded to the triple store server, which was in the cloud, and so this is not reflected here, the query processing itself. So how can we get there? Basically, we think that we need to move on from linked data also to linked software, so that we not only have RDF and linked data on the boundaries of our data sources, but we need to integrate it, the RDF model deep into our software, so then we can reap the generic benefits and the declarative, and use the declarative paradigm. So how can this actually be designed? So the main idea is that there are classes of resources, of RDF resources, and most of the resources that share the same URI template, they also share the same representation template. Basically, all items matching a person, they have an RDF structure somewhat similar. So, and what it means basically that URIs map to SPARQL queries, and this can be defined declaratively. There is a syntax for URI templates. There is a spin syntax to express SPARQL as RDF. So those can be combined into an ontology that can be processed afterwards. So some of the implementation steps basically that we need to push as much logic from the imperative code, such as Java or PHP or Python or whatever, into RDF as much as possible, and then go for native RDF processing. Use native RDF tools. Throw out the object layers if we don't need them. I mean, if we have object mappings on top of RDF, basically then we lose the advantage of RDF flexibility. But if we can avoid those object layers and go straight for RDF, then we can have the generic advantage. So then, and this fits nicely with functional code. Also, we use templates everywhere. URI templates, SPARQL templates, XSLT templates. There's templates everywhere. And it helps to have Spin as a SPARQL meta model, in that sense that SPARQL itself can be manipulated as RDF, which has some interesting effects that you can manipulate your queries on the fly. That's what we do with facets and with pagination, with ordering. Basically, we change the query structure on the fly, then generate the query string, and then send it to the triple store. And then transformations between formats is an important thing. For example, people are talking about JSON LD or RDFA or some other serialization formats. But this is really not important. If you have RDF, you can switch between the formats just like this. So, and the key technologies that are used to implement this in our platform, what it does basically just combines those technologies into one piece of software, but they were defined well before. So as I mentioned, spin to meta model Sparkle is one of the cornerstones, and then RDF post encoding that not so many people know. Unfortunately, it allows to encode RDF straight as RDF inputs, as HTML inputs, I mean, as standard form inputs. So they can either be visible, where you get value from user input, or they can be hidden, where they carry on properties or types that you don't want to show to the user, but that are still present on the page and will be submitted with the form. And then we use XSLT2 a lot, as I mentioned also before, both on client side and on the server side, and we just transform RDF. XML, some people say it's hard, but we just think it's straightforward. And then there's the link data platform working draft right now. I don't think it's a specification yet. And we think that our platform is actually more general than that, and we could implement this standard using our platform. But that's not our goal, basically, but because we think the tight coupling with Sparkle is important, because Sparkle is the query language for the semantic web, and the link data platform specification, it doesn't take that into account at all. Maybe I can show just a few code examples in the end. I don't have a long presentation for this one, but you can join us. We created a community group on W3C not so long ago, where we want to standardize this approach. We called Declarative Apps, so you can join us there. There's also some draft version of how the specification could look like on GitHub. It needs some updates, but we'll get to that. And of course, you can check out the code, which is open source and which is on GitHub. I'll just show a few code examples, and here are the contacts, of course. So basically, come on. Okay. Well, this is how the sitemap looks like of this Danish newspapers project. So yeah, we have a bunch of namespaces, of course, for on the ontologies. And then we have the static resources or containers that will be in the application defined here. They have FOF and SIOC types mostly. And there's a bunch of those. Then we have the templates, which is probably the most important part. And this is, for example, the newspaper container part, which has a restriction on URI template value right here. So this template will be executed well when this newspaper's URI is matched, or relative URI, relative to the base URI. And this is then connected to the spin query, actually spin query template, which goes here. And this is basically just a Sparkle query string that defines the shape of the newspaper representation. But behind the scenes, it is parsed into spin, and then afterwards we can set dynamically those things as limit and offset and filters and so on. And what else we have here? We have the user accounts. For that we use mostly FOF and SIOC again. Yeah, those are the users. And we have authorizations as well, for which we use the W3C ACL ontology. And then authentication and authorization are checked basically as a transparent filter by the software. So if you don't have access to a certain resource or a class of resources, you just get access denied or forbidden or something like that. So that is it basically. There are a few more queries, and here's also some XSLT2. It's probably not for everyone, but when you imagine RDF XML in your head, it all makes sense actually. So it's just templates, templates, templates everywhere. Yeah, I guess that's it for now. Thanks.